we're going to look into solving inequalities. So here's our example here. We have some polynomial, and it's telling us it needs to be greater than 0. In other words, what they're looking for is the positive values of this function, whatever it is. Now we're using a function that we might already be somewhat familiar with. Two sets of bracket, and an x in each one. Do you know what the power of this function is going to be? 2. So it's a quadratic function, which is something we've studied a little bit. So what that means, okay, is I'm just going to draw a rough sketch of this here, is that we're looking for, I've made the assumption it's opening upwards, that we're looking for when the function is positive. So in other words, when it's above the x-axis. That's what we're looking for. So we're going to find some kind of interval, and we're going to use an interval to represent what our answer is going to be. So there's a couple ways we can go about this. One of the ways is to find out what the x-intercepts are. Okay, so to find the x-intercepts, that's essentially when the y value is equal to 0. Okay, so what I can do is actually turn this into similar to a function. It's not quite this inequality, but I could say that x plus 3 and 2x minus 3 are equal to 0, and then I can go about solving those x-intercepts, and then I use that information. Okay, so that's what we're going to do in this one. So from here, I would split this. I would have x plus 3 equals 0, and 2x minus 3 is equal to 0. Okay. And when I move 3 the other side, x is equal to negative 3. Here we get 2x is equal to positive 3, x is equal to 3 over 2. Okay, so we have two x-intercepts, so I'm going to continue to kind of make rough sketches of what we're doing along the side, and then we'll kind of pull up a very nice graph of it. So one of the values at negative 3, and the other one is at 1.5, so 3 over 2. Okay. Now, I know, because I know quadratics quite well, that this is going to open upwards, but we should really prove it. Okay? And if it opens upwards, I can already tell you what the answer is going to be. If it's opening upwards, that means it's positive when it's less than negative 3, and positive when it's greater than 3 over 2, and negative in between those two. But we should really verify this. I can't just say I know the answer without proving it, right? So I'm going to kind of build a number line here. So we get a little number line. And on our number line, what I'm going to work with is there's the value of negative 3 and the value of 3 over 2. And we know that at those points, y is 0. Okay, so y is 0 at these 2 points. So what we're going to do is we're going to test for values in between these. Think of these like intervals, okay? So I'm going to test the value over here. So that's any value less than negative 3. I'm going to test the value in between, and I'm going to test the value greater than 3 over 2. So any value less than negative 3, I'll use something like negative 5. Okay, that's less than negative 3. I'm going to take that number, plug it into the equation, and see what value we get. Okay, so the equation read x plus 3 and 2x minus 3. Good. 2x minus 3. Okay, so we're going to replace the x's with our new testing values. Okay, so we get negative 5 plus 3. And once you get good at that, you might be able to do a lot of it in your head, but we're going to work this all out. Minus 3. Okay. So negative 5 and 3 is going to be negative 2. Okay. 2 times negative 5 is negative 10. Minus 3 is negative 13. Without even continuing this, I should have equal signs here. I know a negative times a negative is going to be positive. So what that's telling me is my answer is going to be positive in this bracket. The actual value of the answer isn't really that important for what we're doing. Might as well finish it off. It's going to be 26. So yes, 26 is positive. So we know we're positive in this quadrant when we're less than negative 3. Okay. Then I take a value in between. 0 is a pretty nice number to work with. It tends to do a lot of canceling for us. So we plug in 0. We would get 0 plus 3, 2 times 0, minus 3. And then we work it out. 0 plus 3 is going to be 3. 0 times 2 is 0. Minus 3 would be negative 3. So again, I have a positive and a negative. My value is negative 9, but what's important here is that the fact that it's negative. So we know we're negative in this interval. Okay. And then finally, we'll test the last one. We'll just use the value of 2. 2 is greater than 3 over 2. Like we said, we have a decent idea of what we're going to have here. We use 2 plus 3, 2 times 2 minus 3. Okay, this will give us 5 and 1. Our value is 5, but more importantly, our value is positive. So we've just proven that the intervals for this answer, and again, remember the inequality was only asking for when it is greater than 0. So they only care about when our function is positive. So our answer to this would be when x is great. Oops, I should say. What do I have here? When x is less than -3. So we could say when -3 is greater than x, or when x is less than -3, or when x is greater than 3/2. We don't include that interval in between because that's when it's negative. So you can kind of write it as a sentence. Therefore, when x is greater or less than -3 and x is greater than 3/2, x is positive, you could say. However your teacher wants you to use your answer is kind of up to your discretion here. I want to see quickly. Oh, good, I have Desmos up. Let's verify our answer here. X minus 3, was it?
Yeah.
And
X plus 3.
what was it? X plus 3? X plus 3 and 2x. Remember what it was?
2x
minus 3.
Yeah, minus 3.
Yeah. 2x minus 3. There it is. Here's our -3, positive 1.5. That's exactly what we found. Our interval is positive over here, negative down here, and positive over there. We're great.